Hi guys, let me take you through the solutions to the questions we talked about in class here. So out of chapter number 1, question 1.5, use the distance formula to find the length of the segment with these endpoints. So here's the distance formula. It is the square root of the difference between the two x coordinates. We square that difference. And then to that, we take the difference of the y coordinates. That quantity is squared. And we add those two squared quantities together. So the order in which you subtract here doesn't matter. 4 minus -2, there's the difference of the two x coordinates. So I'm going to write it out carefully here. 4 minus the -2. We'll square that. And then the difference of the y coordinates, 8 and 3. We need to take 8 minus 3. We'll square that. So, of course, subtracting the -2, that's the same as adding 2. This is 6. 6 squared makes 36. This is 5. 5 squared is 25. And then, literally, to finish the question, 36 and 25, that radical is essentially a grouping symbol. So you need to do that addition before you worry about taking the square root. 36 and 25 make 61. And if you look at the directions, I wanted an exact answer in simplified radical form. Well, there isn't any way to simplify this, so you can actually stop here, the square root of 61. So question 1.6 is essentially the same type of a question. So again, distance formula. So we need to take the difference of the x coordinates. We'll start there. So -3 minus 1. There it is. We'll square that quantity. The difference of the y coordinates, 5 minus -1. Square that quantity also. So the -3 minus 1, that's -4. -4 squared is a positive 16. 5 minus -1, that's going to make a 6. 6 squared is 36. So the 16 and the 36 together make 52. Now, 52, this is a number where when I take its square root, I can simplify it a bit. So I'm going to come over here. I know that you've seen something like this before where we can take the 52 and break it down into its factors. 52 is an even number, so probably the simplest thing to do is to divide by 2. That would be 2 times 26. 26 is also an even number. That's 2 times 13. So notice when I made that factor tree, I have 2 factors of 2 and then the 13. So the square root of 52 is really the same thing as the square root of 2 times 2 times 13. So this 2 times 2, that's really a 4, and the square root of 4 makes 2. So I can simplify this by bringing this double factor of 2. I can bring it outside of the radical. And then the 13 remains under the radical. 2 radical 13 is the simplified answer, simplified radical form. I know we did question 1.7 in class. Let's look at 1.8. So again, we have a segment DC. Its endpoints are -3, -8, and C, those coordinates for the other endpoint, -2, 2. So if I want to find the midpoint, remember, all I need to do is find the average of the x coordinates and the average of the y coordinates. So the x's are -3 and -2. So literally to find their average, just like averaging any two values, I add the -3 and the -2 together and divide by 2. And to get the y coordinate, same thing. -8 plus 2. I will add them and divide by 2. So literally to find the midpoint, I want to find the middle of the x's and the middle of the y's, and I do that by averaging. So this is -5 divided by 2. You would be welcome to leave that as -5 over 2. You could also write it as -2.5 if you wanted to. -8 plus 2 is -6. -6 divided by 2 is -3. there are the coordinates of the midpoint. Literally, the negative 2.5 is exactly in the middle of the negative 3 and negative 2. So that's the average of the x-coordinates. And the negative 3 is exactly in the middle of negative 8 and 2. There are the coordinates x and y for your midpoint. Continuing on then, out of chapter 2, a couple of the questions that I wanted you to consider here. Here are given statements and conjectures. And our job is to draw and label a counterexample. So what we want to see here is under this given. So if we really do have angles 1 and 2 as congruent angles, the conjecture is that 1 and 2 have to be vertical. Well, they don't have to be vertical. So what I want to do is show a picture where the given is satisfied, where the given is true, but the conjecture isn't. So essentially what I want to draw is a picture where 1 and 2 are congruent, but I want to show that 1 and 2 don't have to be vertical. So I really want to show this. They aren't vertical. So there are lots of ways that you could do this. So you could just, frankly, here are two right angles. There we go. Angles 1 and 2. So those are definitely congruent angles. They're both right angles. So it satisfies the given, but it doesn't satisfy the conjecture. Angles 1 and 2 are certainly not vertical in any way, shape, or form. That's a counterexample. Has to satisfy the given, but not the conjecture. I mean, there are lots of ways that you could do this. After school today, in period 6, someone did this. Someone drew a picture that looked like a parallelogram. So here I'll even label as a parallelogram. You don't have to do a counterexample quite this fancy, but I thought this was a nice counterexample. And then what they did was they labeled the opposite angles. Fine. Angles 1 and 2, they're opposite angles in a parallelogram. They're congruent, but they're not vertical. You could make lots of counterexamples. So the next one, question 2-4. I want triangle ABC to be isosceles, and I want AB and AC to be the congruent sides. So I want those to be the congruent legs. The conjecture is that the triangle has to be an acute triangle. That's not true at all. I can make an obtuse triangle. So I can put an obtuse angle in. So the two congruent sides need to be AB and AC, so A should be up at the vertex. There's AB. There's AC. And maybe this is a 95-degree angle here. So here is a counterexample. Is triangle ABC isosceles with AB congruent to AC? You bet it is. Now, does the conjecture fit? Is triangle ABC an acute triangle? No, it has an obtuse angle in it, so it is not an acute triangle. So, continuing on, out of chapter 3, the questions that I had suggested out of chapter 3 are 3.6 and 3.7. These are algebraic style questions. Here, let me focus the camera just a second. There we go. So the diagram at the top then, this is the diagram for all of the questions 3.1 to 3.7. So in question 3.6, the question says that angle 5, there we go, is 3x plus 14, and angle 3 is 2x plus 16. So let's find the relationship between angle 5 and angle 3. If we go up to the picture, here's angle 5 and here's angle 3. Those are same side interior angles. So I have parallel lines A and B. So those same side interior angles are supplementary. So if I want to solve for x and then find the measure of angle 3, I need to take these two expressions, the 3x plus the 14, that's the angle 5, and the 2x plus 16, that's angle 3, and I need to add them and make them equal to 180, make them supplementary. Combining our like terms, 3x and 2x makes 5x, 14 and 16 makes 30. So if we subtract 30 from both sides of the equation, 5x equals 150. So if we divide then by 5, x is 30. So we are part of the way. We haven't finished the question though, because our job is to find the measure of angle 3. So here is the expression for angle 3, so I can substitute it in. The measure of angle 3 is just 2 of my x's, so 2 of my 30s, plus 16. 2 times 30 is 60. 60 plus 16, 76. There you go. Don't forget to answer the question. So if you have an algebra problem, you need to set it up and solve it, but then don't forget to answer the question. We're not just finding x, we had to find the measure specifically of angle 3. So question 3.7, a different relationship here. So now we have angle 8 and angle 4. So let's go to the picture and make sure we know how 8 and 4 relate. 8 and 4 are corresponding angles. Again, because we have parallel lines, those corresponding angles are congruent. So I'm going to set these expressions equal to one another. So 5x plus 85, that should equal 12x plus 57. So to solve this, we'll subtract 5x from both sides. So that will leave me with 7x. And then also we should subtract 57 from both sides. So that should leave me with 28. So the 7x remains on the right. We have 28 on the left. Divide by 7. X is 4. Now we're not done because our job is to find the measure of angle 8. So we have to finish the question by substituting in. The measure of angle 8 is 5x plus 85, so we need to take 5 times our x value plus 85. 5 times 4 is 20. 20 plus 85 is 105. There we go. So this video is already a little past 12 minutes long, so I think it makes sense to upload them in smaller chunks. So this finishes chapters 1, 2, and 3. I will make another video then where we will take a look at 4 and 5, and we will also take a look at the proofs that I had suggested that you do. So I will give the next video, I will give it the same name, but afterwards I will just put number 2. So same name, but then I'll just put number 2 after it so you'll know which one to click on. Hope this has been helpful.